Welcome back to my channel. Today I want to show you about my presentation about coping with corrosion. So the reference for my presentation is from book Metalurgy for the Non-Metallurgy by Arthur C. Reardon. So this is my agenda. First with coping with corrosion. 15.1 The mechanism of corrosion metals. 15.2 Form of corrosion. 15.3 Corrosion preventive or mitigation. And first, the mechanism of corrosion metals. The word corrode derived from the Latin corrode, which means to gnaw away. While corrosion can occur in many different forms, it is more generally defined as a chemical or electrochemical reaction between a material and its environment that produce the deterioration change of the material and its properties. In the most common use for the word corrosion refers to electrochemical oxidation of metal with corrosion, often producing oxides and or salts of the base metal. The mechanism of corrosion metal corrosion involves a branch of chemistry called electrochemistry, which is a study of two basic types of reaction: chemical change that produce electricity current flow, and conversely of electric current that cause chemical change. Electrochemical reaction basically involve the transfer of electrons by two types of partial reactions, referred to as oxidation and reduction. Oxidation is the electrochemical process of losing an electron during a chemical reaction, while reduction is the process of consuming or reducing electron in reaction. Corrosion cells and battery, both oxidation and reduction reaction must take place for corrosion to occur. During metal corrosion, the areas over which the anodic and catalytic reactions occur may both vary gently, from areas of few atoms or parts to areas extending to hundreds of square meters. Galvanic series. The previous example illustrates the basic electrochemical reactions in the corrosion of two metals. It also introduced the concept of oxidizing power or potential of different metals. The oxidizing power of a metal is its ability to build up a voltage or electromotive force or EMF from removal or addition of electrons by the electrochemical process of oxidation of reduction. Passivity. Essentially, passivity refers to the loss of chemical reactivity experienced by certain metals and alloys under particular environmental condition. That is, certain metal and alloy become essentially inert and act as if they were noble metal, such as platinum and gold. Fortunately, from an engineering standpoint, the metal most susceptible to this kind of behavior of the common engineering and structural materials, including iron, nickel, silicon, chromium, titanium, and alloys containing these metals. Also, under limited conditions, other metals such as zinc, cadmium, tin, uranium, and thorium have also been observed to exhibit passivity effects. 15.2 Forms of corrosion. During metal corrosion, the areas over which the anodic and catalytic reaction occur can vary gently. This results in various forms of corrosion such as uniform attack, pitting, and creep corrosion. Uniform corrosion, or generally corrosion, is a corrosion process exhibiting uniform thinning that proceed without appreciable localized attack. It is the most common form of corrosion and may appear initially as as a single penetration, but through examination of the cross section it becomes apparent that the base material has a uniform thin intergranular or IG corrosion is the preferential dissolution of the anodic component, the gain boundary faces or zones immediately adjacent to them, usually with slight or negligible attack on the main body of the grains. Pitting corrosion. Pitting characterized by sharply defined holes. It is one of the most insidious forms of corrosion and can cause failure by perforation while producing only a small weight loss on the metal. This perforation can be difficult to detect and its growth rapid, leading to unaccepted loss of function of the component. Crevice corrosion is pitting that occurs in slots and its gap at metal to metal and metal to metal interfaces. The mechanism is the development of a concentrate corrosion cells. Corrosion fatigue is caused by repeated or fluctuating stress in a corrosive environment. Fatigue life is shorter than would be expected if the sole cause was either repeat of fluctuating fatigue or a corrosive environment. The environment is a key factor is the type of corrosion. Selective leaching. In selective leaching, an element is removed from the alloy through corrosion. The most common example is densification or removal of zinc from brass. Stray current corrosion. As an electrochemical process, corrosion can be influenced by electric potential. Stray current corrosion or stray current electrolysis is different from natural corrosion because it is caused by an externally induced electrical current and is basically independent of factors such as oxygen concentration and pH. 15.3 Corrosion's prevention or mitigation. Corrosion, although corrosion is seemingly pernicious process, it can be disrupted by breaking the oxidation reducing loop of an electrochemical cells. Difficulty it is complexity, for example, evaluating the corrosion exposure condition for metallic piping, network require an understanding of various field conditions such as soil type, soil pH, stray current effects, and electrical continuity. So also there is a corrosion inhibitors, anodic protection, and control pH corrosion with propagacy diagrams. So thank you for watching my video. I hope you guys enjoyed. Sorry for my misunderstood words. See you on the next video.